This example has a little bit more going on with it. So we're still going to draw something continuous, so something we can trace without having to pick up our pencil. And we want to draw something where it is decreasing at first. F prime is less than 0, so we want to be decreasing. And we're also told that F double prime is less than 0. So we're going to draw something decreasing and concave down. And that's at least from negative infinity to 0. So we're going to switch at x is 0 to where we have the first derivative is less than 0. So we want to be decreasing again. But the second derivative is bigger than 0. So we're going to be decreasing and concave up from 0 to infinity. It's on the other half of the graph. So let's narrow this down piece by piece. So first piece says we want to be decreasing and concave down. So that concavity gives us a really good idea of what the picture would look like. So concave down is a full upside down U, just the left side or just the right side. We want to trace it and figure out which one's falling. So this one's rising, then it has a 0 derivative, and then it's falling. So that's not our picture. This one, as we follow it left to right, it's rising, so that's not decreasing. But this one, you follow it left to right, and it is decreasing. So this one's increasing, has a 0 derivative, is decreasing. This one's always increasing. This one's always decreasing. So that would be the picture we want to draw. From negative infinity to 0. So I'm going to switch at x is 0. It doesn't tell me the y value to switch at, so I get to pick the y value. So I'm going to just randomly choose 0, 2. You could choose any y value. You could shift this up or down. And I want to draw something decreasing and oriented downward. So I literally want to draw this picture, but bigger on the graph. So I'm going to take and draw this picture, decreasing and concave down. Okay. And then I want to draw the other part that says decreasing and concave up. So I want to draw decreasing but concave up. And the concavity gives us a really good picture. I'm going to draw my 3 options for concave up and figure out which one's always decreasing. Is it the first, the second, or the third picture? This is decreasing. It has a 0 derivative at the critical number. At that soft peak, then it's increasing. This one's always falling. This one's always rising. So we want the second picture. We want to draw that, but just bigger on the graph, something that's falling left to right, but it's oriented upward. So I can draw that anywhere I want to. Maybe I'll have it look like that. It's decreasing, but at first it looks like it would be part of what would be an upside down U. And then over here it would be part of a right side up U. So decreasing everywhere, but flips from being concave down to concave up. There are many answers for this as well. This is also continuous because you can draw it without picking up your pen. Something I do want to know is this would be a lot easier if it didn't have to be continuous. So if it didn't have to be continuous, which you'll see on the practice test, not all of them have to be continuous. So if this didn't have to be continuous, how would I draw it? So I'm going to give myself a little graph. And if it didn't have to be continuous, let's say it still had to be these same things. It still had to be decreasing and concave down before 0. So I could draw it anywhere I wanted to, decreasing and concave down before 0, and then decreasing but concave up. That same shape as that middle piece, decreasing but concave up. And then I could just put a vertical asymptote at 0. I feel like it's a lot easier to draw and make the concavity clear, as well as that it's decreasing very clear without having to make it continuous. I think makes it a lot simpler to get the point across.